This is our klystron power supply. This is the power switch. This is the AST switch. AST is on. Then power supply produce electron beam. This now varying beam voltage and beam current. This now varying repeller voltage. This now varying frequency for amplitude modulation. This now varying amplitude for amplitude modulation, and this now varying frequency for frequency modulation, and this now varying amplitude for frequency modulation. This is the modulation selector switch. The modulation is CW, AM, FM and EXT. EXT mode, select the EXT signal, feed this point, and this is the output of this power supply. And this is the meter selector switch. The display showing voltage, that is repeller voltage, and this is beam current, this is beam voltage. Now I am set the modulation AM mode. Then the next part is klystron oscillator. This is klystron mount and this is klystron tube. This is the isolator. Isolator allows the signal only forward direction. This is the variable attenuator. This is frequency meter, measure the resonant frequency. This is slotted section, that is set, minimum mode and maximum mode. This is tunable detector. This is mass termination, CRO and VSWR meter. VSWR meter scale is 4 scale are there. One is upper, one is SWR, then expanded SWR, then dB, and last is expanded dB. This is the power switch, and this is the meter selector, expanded, normal and dB. This is the range selector, range in dB. This is input selector, always set 200 ohm. This is the 2 knob gain selector, that is fine, that is coarse, and it is the input point of this meter. This is the model graph. The reflex klystron oscillator. This is power versus repeller voltage graph, and this is frequency versus repeller voltage. Now the reading table is repeller voltage, frequency and VSWR reading. At first, set the power supply any maximum mode. Now I am set. This is 126. Now set this power supply maximum mode and slotted section move the maximum position of the output signal. This is the maximum output signal. Now I am set this maximum peak repairer voltage, set this point, and note down this value. This is the beam current. Now beam current is 0.016 ampere, and this is beam voltage 222 volt, and that is repairer voltage. This is the midpoint maximum peak voltage. Note down the repairer voltage. (124 volt). Then the frequency is rotated the frequency meter. Now clipping the output signal, then stop rotating, and the value is 2 copper foil are there and 1 red line meet this point. This is your resonant frequency, that is 9.74 gigahertz. Now reduce this value. This is 116. This is the output waveform. The frequency is there, that is 9.73. The frequency is 9.73 and the voltage is 116. Now I set the maximum peak 124 and increase the value. Next, low level value, that is 132 volt, and draw the output waveform and measure the frequency, rotated the frequency meter and showing the output. That is 9.75 gigahertz. Note down the value. Frequency is 9.75 gigahertz and repairer voltage is 132. In this experiment, always variable adapter set at the top level. Now I am set the value maximum peak, that is 124 volt, and the output probe is connected to the VSWR meter. Now VSWR meter set the value 1 dB or 0 dB. Now it is set 0 dB at top value. Note down the VSWR reading is 0 dB. Then the varying the reply voltage 116 volt, volt. Then showing the output of the VSWR meter. Scale is crossed. Now add 10. Then it is 9 reflected. 9, then it is 9. Scale 10 plus 9, that is 19 dB. Note down the value minus 19 dB. Now it is set 132. Then show the value of VSWR meter. Meter reading is crossed. Then adding 10. Then showing value 9. Then showing value 9 or 9, varying to 9. So reading is 9 and plus 10, that is minus 19 dB. This is our reading. (116 volt), frequency 9.73 GHz, and VSWR reading in dB minus 19 dB. Reply voltage 124 volt, then frequency 9.74 GHz, VSWR reading 0 dB. Reply voltage 132, then frequency 9.75 GHz, and then VSWR reading 19 dB. Now plot the graph. One is mode of reply voltage versus output power, that is VSWR reading. Output power means that is VSWR reading. So x-axis reading is reply voltage and y-axis is power. Then reply voltage 1 on 16 here, 124 here, 132 here. Now this axis is power axis. At the top level power 0 dB, then minus 5 dB, then minus 10 dB, then minus 15 dB, and this is minus 20 dB. (116) power is equal to 19 dB, then this is 20, this is 90, 19 dB here, and 124 power is 0 dB, 0 dB here, and 132 power again 19 dB, that is here. Now joining these 3 points, this is the curve of repellent voltage versus power. Now draw this curve, repellent voltage versus frequency. This line is here, and this is the frequency point. Y-axis is frequency. This is mid frequency is 9.74 gigahertz. This is 9.74 gigahertz, and lower frequency, this frequency is 9.73 gigahertz, 9.73 gigahertz. This frequency 9.73, and this frequency is 9.75 gigahertz, and this frequency is 9.74 gigahertz. And join these 3 points. This curve is repellent voltage versus frequency. This is the characteristic curve of a reflex klystron oscillator.